Hello all, welcome back to Cybercreate. Today in this video, we are going to be discussing about the image similarity search. So let's suppose you have group of different images out there and you basically want to filter or group all the similar images together. So how you can do that what we will be discussing today. So if I have 3 or 4 faces of mine and 3 or 4 different images of my different friend, and if I want to group them and find the similar image, how can we basically achieve that? So that is what we will be discussing in this video. And if you are interested, please make sure to watch the video till the very end because we will be discussing so much new things and concept that you will get to know today. So in order to do this, what actually we are going to do is to basically take all the images and then start basically converting them into vectors, and that we will do by just selecting image one by one. So we will take the first image, normalize it, and make sure that their dimensions of each images are just same. We have to basically scale down into a single dimension because that is going to be very necessary, because we are going to be using a pre-trained ResNet model that will basically extract feature from that image and then return a 512 dimension vector. So not dimension but 512 length vector that we will be using for each and every image. And let's suppose we have entered 20 different images in our vector store in that particular way. Then once some new image comes, we can basically ask, hey, whose face is this falling to? Then again the same process is going to be generated. We are going to take my face, it is going to be converted into the form of vectors, which is nothing but a list of numbers for normal understanding. This will be thrown into the dimension space of the vector database that we will be using. And then we can basically set a threshold, like only if the distance between my image and the other images is like 0.2, like they are just very close, like 0.2 in 0.2 centimeter or inch. You can basically try to think in that term. So whichever image is basically going to be closer, just find me all those images, because if we let it find the nearest 5 or 10 images, it can basically pick other people images that are not actually similar to mine, not actually like same face as mine. So this is what we will be going to do. So this is the process. Now let's start coding. So first of all, we will be using PyTorch, as well as for the vector database we will be using the Redis as a vector database because it is one of the most popular free open source and things like that model that is actually available. And here I have imported some of the important libraries that we will be going to be using for the image extraction feature. So we are to basically extract the features out of images. So for that we are going to be using ResNet 18. So you can basically also create your own model, or you can use other better model if you want to get much more better feature extractions. It all totally depends on you. I'm going to be showing you a base case and then you can optimize it as per your own knowledge and requirements. So here I am using ResNet 18. So here this is how we basically define ResNet 18 with its default weights. So whatever the default weight, just take it. Here we are defining the model, and then here we are defining how we are going to be transforming our images. And once this is done, we are now going to be focusing on writing a function that takes the image, read it, apply, transform that image into the particular required dimension so that all the images are in the same scale. So this is the function. This is the generate image embedding. So we have to basically generate the embeddings out of our images. So firstly, we are going to open the image. Then we are going to basically transform it, which means doing the pre-processing of the image and then basically add to a batch dimension. And then here we don't actually need to compute gradients. So we are saying torch.no gradients and we are extracting features. So this extract feature variable that we have created, this is going to extract the features out of the image, and then we will be just getting the embeddings, and then we are basically going to be removing any extra dimension that it have, and we are going to flattening it so that it flattened and become into a one dimensional array, or you can simply say list, and then we are going to be returning it as an embeddings. And let's try to see with some of the images that I have. Let me show you some of the images that I can basically show. So this is the folder of images that I have, and there are, you can see there are different type of images. So here is one image of mine, and here is other image. So here these are the images, and now here in my code what I'm passing, here I am basically passing one of my image one, which means this is the image that I will be passing. And just to help you understand what this function is doing, first, if you are going to say Python main.py and you are going to run this, this will extract the vectors. So you can see this is how this vectors is basically going to be looking like. So this is the embeddings, and this is in a single dimension. It's a single dimension list. So you can basically see this. It's a single dimension list. So that is what it is. So now here we now know how we can do this. Now we are going to write other main function that is going to use our Redis as a vector store, and then we can do the similarity. So till now we have just made the progress to extract feature out of this image, and we have written the function. So this is what we are going to apply for all the different images, and only then we can find the similar images. So here I basically written this main function, and we are going to be seeing about this Redis vector database. So in order to use Redis vector database, you basically need to either install it on your server, or you can basically use a Docker container. So here my Redis was already running, but I will just show you how we can run this. So this is the command that you can use if you have the Docker installed to run the code. So Docker run this, and once you start this, if you have not already downloaded it, the Docker container will automatically download it, and once it's downloaded, then it will run. And as we are using the Docker, it is going to be running on our local host. You can also use the cloud. So this is the class that I have basically written. Let me go to the class. This is the class that I have written. And yes, just to make you aware where I got this. So this is the document, some of the documentation that I have gone through. And you can also go to this, and I have basically taken some part of the course from here and modified it as per our own needs. So here it have basically explained all of the things, like index creation, adding vectors to the database. So firstly, we have to create the index in the Redis, and then in that particular index, we will be saving all of these vectors. So as we have seen in the example, after extracting features, we are basically getting the vector. So we can add the vectors using this part of the code that is basically shown here. And then for searching, which means to find the nearest ones that are basically very similar. So Redis takes care of it. It uses the KNN like that finds the k nearest neighbor thing. So this is the code that I will be referring to, and also I have been going through this docs for much better understanding. I will provide the links so that you can also do the same. So let's jump to the code if you are interested in that. So here I have created this, and here are some of the important imports. So I will provide the requirements.txt in the GitHub so that you can use the code as well as the requirement.txt file so that you can get the same requirements as of mine. So here, this is the first thing that we have to basically do. Here I am basically trying to establish the connection, and then I have written this check connection function. So check connection is just nothing. It is simply going to it is simply going to ping the client, and then it is going to say, hey, if your Redis connection is already up and running, and if there is any problem, first make sure to fix that. First make sure to establish the connection on the Redis, and then only we can proceed further. So once that is done, let me just minimize this to the lowest point. So next thing is to basically create index, and here also I have taken the reference from this particular code of creating the index. So okay, this is the index creation that it have dictated. So here firstly we are getting the index name.info, and we are checking if the index already exists or not. So here we are in the try and catch. So if the index already exists, we don't actually need to keep on creating it. And then here we have to basically pass the vector dimensions. So here in this particular model that I am using is ResNet 18, the dimension is 512. So if you are going to use some other models, make sure to pass it in that particular format. And if I go to the main.py, here I pass the vector dimension. So this 512 is nothing but whatever the dimension that you are getting out of your embeddings. So make sure to use that only. That's an important point when you are going to modify the code according to your own needs. So it is going to be float 32, and here in the distance matrix I have defined cosine. There are other distance metrics that you can also use, and you can play around with it to see what is working fine for you. So now here we are defining the index, and then we are simply creating the index, and once it's created we are printing, hey, the index is successfully created. And then thus next steps comes into action, which is to basically store the vectors. So why we are basically going to store the vector is because we are going to take the image. We are going to take in which index it have to be saved, and we are going to save it inside our vector database so that all the images are inside this vector store. Then and only then we can find all the similar one that would have been forming the form of clusters. So here what we have done here, this is also the code from the documentation. Here I am basically writing the Redis key. So docs colon, which is going to save the key into this particular prefix. And then I am also saving some of the metadata, like the name of the images, because the Docker supports it. And now here is the main thing. Here we are saving the vector, which is the vector that we are getting out of our image, which is nothing but the image embeddings. And then we are basically saving it into our database, and once it's stored, we are successfully printing it. And now the next important thing. So you have the image, you have selected the Redis as your vector store, you have inserted your all the images into the Redis vector data, and now the next most important things come into action, that is to basically fetch all the similar results. So here this was the function that I wrote for debugging purpose. It just don't serve any real world purpose. This was to fetch all the documents just for debugging. If you don't want, you can simply delete it. This will not break anything, but this is just here to check or debug if you are even able to get all the embeddings out of your documentations or not, or Redis or not. So I'll not be explaining that. But here is the main with the search similar vectors, which is going to search the similar vectors. So here we have to pass the index name, the query vector. Let's suppose the new image comes, so you have to find which like my face image basically pop-ups, and I have to check which is this image similar to. So this is that we are going to be passing, and top k, because this is the k nearest neighbor, whatever the top k you want to send. And here is the threshold part. So let's suppose my similar image, there are 5 different persons image. So if as they are people image, they are going to be somewhat very similar to as the image of some car, mobile phones, laptops, tablets, and things like that. So we have to also define the threshold so that the face just similar to mine, not other people's face, not other humans' face, should be detected. So here we are setting that threshold. So threshold here means the distance. So this will be as close. So if two things are same, the distance will be 0. If they are just a bit different, the distance will be like 0.0001. And farther they are, which means they are not similar, their distance will be 10, 20, 30, and it will keep increasing. So you have to keep that in mind. So if you want the similar, you have to keep it closer. And that is why here I am basically writing the query. And this k nearest neighbor also provides the score, which is nothing but the distance. So here, once this query parameter is, we are basically passing our image that we have passed. We are getting all the data, and here, if the threshold is not none, which means we have passed the threshold, then here we are getting that score, and we are just taking only those which are basically less than our threshold. So let's suppose you have provided 0.2, so which means anything that have the distance less than 0.2 are going to be similar, so that it makes sense. So yes, I try to explain this in as clear as possible so that you don't get confused, because I was actually when I was trying it for the first time. So now let's move out to the main code. So here we have defined the Redis. So here the password is none, so we have defined the password none. Here we are passing the index name, whatever name of the index that you want to create, you can simply pass it. And the vector dimension I have already explained, the dimension of the embeddings of our images. And if you are using other models, make sure to update it there. And here we are creating the indexing for our index name with the vector dimensions. So here the index is going to contain that much vector space. And now let's move ahead. And here are some of the images. So here I have defined the image path. And here I will be looping up to all the images, and basically going to be generating the embeddings. And for the file name, I am just taking image1.jpg. This is nothing but that. So firstly, I am generating each image embeddings, and then saving the file path, file name, which is going to be used as the metadata that we have already seen here. So file name is going to be metadata, so that we can actually know which file is there. So you can use it for multiple use cases. You can simply pass the file path. So once the similar image is fetched, you can simply display it on the web. And here we are checking if it's the whatever it's the instance of embeddings or not, and if it's they're good. And here we are basically passing the metadata, and then we are basically storing. We are calling the db.store vector. So it is going to call this store vector. Where it is here, this is the store vector that it is going to be calling. So now again moving up to our code, once this all images vectors embeddings are saved, now we have to basically find the similar image. So here I am basically passing the image 2, and here I am again generating its embedding. So I have passed my face, I have generated my own embeddings, and then this embeddings will be tried to be matched with all those different images that we have inside our vector database, and just those images is required to be picked that have this particular threshold. So here I am doing the similarity search, and then I have set the threshold to 0.2. So all the images that are just very close to 0.2 should only appear, and then I am printing the similar images. And if I now run the code, let me also first comment or delete this, because we already understand how we can make use of it. So here vector embeddings is basically stored, and here the document name image1 is basically found very similar. And here if you see, image1 is in the database, in the our vector database, and here what image we have basically passed is the image2. And if you go and see, we have basically passed image2. So image2 is nothing but my face, and image1 is what it have basically found as a match, because there are different images and we have passed the k-nearest neighbor as 3, but only one of them has satisfied this threshold. So we have just taken that. So let open or the image one. So this is the image basically that I have passed to the model. And if you see the other images, so this is just some random images, and this is also one of my image. But here I was not, my face was not clearly visible, so this is also thresh not included. So yes, this is how you can basically find this use case of generating embeddings and finding the similarity search in the images. So this is something new, you can try it, and this is the basic idea, and you can take this basic idea to create even the facial recognition system that detects if two faces are similar or not. Like the face unlock, this is the base logic that's behind the face ID or the face unlock feature of most of the phone, and this can also be used to cluster and group together the different similar images that are basically used by the Google Photos. So yes, this is just the beginning, and I have given you the base point, and you can start building your own projects from here. And if you have enjoyed this video, please make sure to like and subscribe to this channel, and that will be a great help, because this took lots of effort and time to basically make this video, and I was awake all night doing the research. But yeah, that's what I do. So bye, meet you in the next video.